Welcome back. So in this introductory video to section 1.2, I want to talk about two things. I want to talk about this reduced row echelon form, okay, which I said our goal is going to be to get an augmented matrix in either reduced or row echelon form so that we can solve the system. So I want to define precisely what that is. And then I want to talk some about solving the system once it's in that form. What's not in this video, because I'm trying to keep these relatively short, but we will talk about in class, is how you get it in this form. How do you get it in row echelon form? So we want to look at the definition, but to start with, I need the idea of what the leading term of a row is. Okay, and so what that's defined to be is the leftmost non-zero entry. So that's leading if you're looking left to right. So it's leftmost. And so so typically if we have a matrix, maybe we have some zeros, and I'm going to use squares for non-zeros. And then maybe we have anything. Okay, so this would be the leading term of that row because it's the leftmost non-zero entry in that row. Okay, so we need that in our definition. So this definition of, so this is row echelon form. And so the first condition is that any row that has some non-zero entry is above rows that are all zero. Okay, so another way of saying this is we want rows that are all zero at the bottom. And right, because we're going to ignore rows that are all zero, we noted that they say nothing about the solution to the system. So maybe we're doing some kind of replacement. We do some row operation and we end up with all zeros here. So what we'll do is we'll do an interchange so that those rows of all zeros are at the bottom. We want the all zero rows at the bottom, and there might be none, or there might be more than one. Maybe there's another one here too. Okay, that's the first condition. That's easy to do, and it's easy for us to get it like that. You just move them to the bottom. The second thing, and this is to give it the triangular structure, is that, so this gets into the leading entry. So the leading entry, if you have a row that's non-zero, so it's not all zeros, is in a column that is to the right of the columns of leading entries in the rows above. Okay, so what this means, so maybe I've got a row of zeros down here, and then maybe I've got a non-zero entry here and something here, and so maybe there's a non-zero entry here. And maybe here. Okay, so these are all the leading entries. And so this one, for example, so it's in a column. This column is to the right of any of these columns that are leading entries above it. So the row above it, the leading entry is in this column, and this column is right of this column. So I wanted to have this triangular structure. And it doesn't have to be immediately to the right. Maybe there's, some other space. I could also have, say, something that's like this. And the column above it maybe is like this. So that the leading entries are like this. It doesn't have to be directly to the right, but it just has to be right of it. Okay, so that we can, and the idea is so we can back substitute, so we can solve. So then the third thing is that, so when we have a leading entry, so in the column of a leading entry, one of these highlighted entries, all the entries below it are 0. Okay, so I mean that's you can see in my picture here. I mean these are all 0. So here I have a leading entry, but below it everything is 0. Below it everything is 0. Below it everything is 0. So if it satisfies all those conditions, that's all it means for it to be in echelon form. Reduced row echelon form, and as I noted in class, that you can do different, the row echelon form of a matrix is not unique. Depending on the operations, you can get it in this kind of form with different numbers. But the reduced row echelon form is unique. So sorry about that. So the reduced row echelon form so that says in addition, so all those three things okay, so the first thing we require is that leading entry is a 1. That just makes it convenient for solving, and that's also what makes it unique. And of course, that's also easy to achieve if we have, some kind of situation where we had like a 3 here. We'll just do our scaling so that we have a 1 here. These will now be different leading entries. Okay, so but we want to be in reduced row echelon form, you have to have a 1 there. And the second thing is you have to have, we said you had to have zeros below, so if this is a leading entry, there's got to be zeros below. But now I'm going to say also above. So the entries in the column of a leading entry, let's just say of a leading entry that are above the leading entry. So same column. are 0. Okay, so that didn't have to be the case here. So in this particular case, I mean, this did not have to be a 0. These could be anything. But now well, this is not this one, because this doesn't correspond to a leading entry. But now I'm going to require that this is a leading entry. Anything above it has to be 0 as well as below. This is a leading entry. Echelon form required the one below it to be a leading to be 0. Though now I'm requiring to be in reduced row echelon form, the ones above it have to be 0. So the row echelon form then is going to be something like, maybe it's, maybe it starts out like this, and then maybe the next one goes over like this, and then maybe, I mean, maybe it goes directly to something else or not. I can write it like this. Okay, so these leading entries, they have to be 1. And row echelon form required below to be 0, and now I'm requiring that it's above to be 0. So maybe let's do that maybe in blue. So that has to be 0, that has to be 0. But these other ones can be anything. So, sorry, this one can be anything because there's no leading entry there. But these other ones have to be 0. Okay, so to clarify, this entry did not have to be 0 because there's no leading entry in that column. So this is a column with a leading entry. If there were anything above it, it would have to be 0. This is a column with a leading entry. We made the leading entry 1, and now we're forcing the entry above it to be 0. This is a column with a leading entry. We made it 1, and now so everything above it has to be 0. But things in these columns that are not leading entries, they can be anything. There's no restriction on them. So when those 5 things happen, then it's in reduced row echelon form. If just the first thing happens, then it's in row echelon form. And we'll do more examples in class. And so then solving the equivalent system from either the reduced or the row echelon form. Okay, so let me again maybe get some kind of example here. Maybe we've got maybe let's use the echelon form, and then this can be anything, and then maybe we've got this could be anything, and then maybe we've got like this. Let's say we've got something like this. Okay, so this is the echelon form, row echelon form. Okay, with leading entries. These are my leading entries. Non-zero entries, they can be any number. Okay, so we identify these columns that have a leading 1. They are these pivot columns. Okay, those are the pivot columns. And those are going to be the variables that we solve for. And they also refer to those variables as pivot variables. And so we solve for those variables. And that's the same even if it's in, if it happened to be in reduced row echelon form, this still has, the only difference would be these numbers here in purple would have to be 1. Okay, but those would still be the ones we solve for. So the other columns are referred to as basic or free, basic or free variables. Either term they use in the text. I think they end up using free more than basic, but when they introduce it, they talk about basic. And so these are the variables that we make arbitrary. Okay, so the point is, so in this particular case, if this is the right-hand side here, so we would solve for this fourth variable. We'd make this third variable arbitrary, solve for the second variable, and then solve for the first variable in terms of all of those. Okay, so that's a brief introduction. We will do more in class and do some examples. And I will see you in class.